grandson of T.H. Huxley, Julian Huxley.
What is the bearing of the laws of heredity upon human affairs? Eugenics provides the answer, so far as this is known. Eugenics seeks to apply the known laws of heredity so as to prevent the degeneration of the race and improve its inborn qualities. Not all mental deficiency is hereditary, but heredity accounts for more of the mild, feeble-minded types, such as you see in this group of men exercising in the grounds of the institution. If carefully trained, they can be taught simple routine tasks. But it would have been better by far for them and for the rest of the community if they had never been born. If we want to maintain the race at a high level, physically and mentally, everybody sound in body and mind should marry and have enough children to perpetuate their stock and carry on the race.
I think that eugenics got a very bad press as a consequence of the social Darwinists at the end of the last century and beginning of this century, and then above all, of course, because of Hitler. And I mean, Hitler obviously has a hell of a lot to answer for in all sorts of fields, but one of the things he has to answer for is that after Hitler, certain things can never be discussed in an objective fashion, and eugenics is one of them. So eugenics has now become a kind of red rag word that immediately sends people into a lather. And I don't think that would have happened but for Hitler. And I'm not saying that they're wrong to get into a lather, but I think that you have to see it in the context of the history of the 20th century.
Darwinism retreated to the universities and museums. Yet even controversies at the heart of the theory itself turned out to have surprisingly human implications.
See, what Darwin convinced the world was that instead of evolution being impossible, he did such a good job at arguing for it, and I respect him mightily for this, that he made evolution be inevitable. Darwin said that if you let enough time go by, natural selection will track whatever changes in the environment or what have you are happening, and willy-nilly you're going to see the transformation of the anatomical features of whatever you're looking at through time.
But Eldridge found a surprising pattern in the fossil record. The creatures he was studying, called trilobites, hadn't changed for millions of years, even though their environments had. He felt this had profound implications for evolution.
You've got millions of years of time going by and not one whit of change in this. And so that's what was the shocking part of it, this realization that evolution is not inevitable. Evolution is not going to happen just willy-nilly with a mere passage of time. Stability seems to be the hallmark of life for most of the time.
It was not just trilobites. Many species remained unchanged over millions of years. What shocked him was that generation after generation, species seemed to resist evolutionary change until waves of evolution swept the stability aside. He called this mysterious pattern punctuated equilibrium, and argued that something more than simple Darwinism was going on.
The stability of species was known back in Darwin's day by paleontologists, but it was sort of shoved under the rug. It was ignored because it seemed to contravene what he was saying, which otherwise made so much sense, basically.
When Eldridge and Stephen Jay Gould published their claim that there was more to evolution than Darwin, they were dismissed by mainstream evolutionists and found themselves accused of heresy.
The original punctuated equilibrium paper in 1973 is really saying rather little, because what it notes is that the fossil record is not continuous and gradual. So if you were a really naive Darwinian who expected to be able to see an absolutely continuous kind of morphing going on from ancestor to descendant through the fossil record, then you're going to be disappointed, because the fossil record doesn't show that. Now the question is, does that mean anything? Does the fact that there are gaps in the fossil record mean anything, or is it just that not everything fossilizes? Well, it's obvious not everything fossilizes, everybody knows that. But is that enough to explain the apparent jumpiness in the fossil record? And what Eldridge and Gould suggested was there is more to it than that, that it really does mean something.
The evolution of one species into another was, according to punctuated equilibrium, not simply a matter of natural selection and how they interact at the level of ecosystems.
I think that genetics is important, has lots to tell us in its own domain, but the presumption has always been in evolutionary theory that in a good sort of standard reduction sort of mode of explanation, that all we have to do is know the mechanics on a generation by generation change. Just know a little bit about genetic drift and natural selection in particular, and you can explain the entire, in principle, explain the entire history of life.
And you can't.
And you can't, because we get these patterns.
The question for punctuated equilibrium was what was producing the patterns they'd observed. They had to move beyond observation to explanation.
Well, punctuated equilibrium is these periods of flux which are just culminations of a buildup of stress on ecosystems. And finally the ecosystem can't take it anymore. And things just snap. Ecosystems will degrade, they'll change very, very rapidly, like a bunch of dominoes just sort of falling down. You lose a couple species, and then the things that were eating them, those species will then be impacted, and if they can't find something else to eat, they're going to go too. And things start popping out, going extinct. The whole ecosystem, internal dynamics is therefore changed. You get patterns of true extinction, bingo, just happening like that, over relatively quick spans of time, tens of thousands of years, which sounds like a lot in human terms, but compared to the stability of these systems for millions of years, it's not.
I find that quite possible. I think there are observations one could make on the fossil record which would help to decide whether that is what is happening or not, by looking at simultaneity of change and things of that kind. At the moment, we don't have an adequate theory of the co-evolution of many interacting species. I mean, I've struggled with it. It's a hard theory, and I don't think we have a satisfactory theory. But until we get some kind of dialogue between the people who look at the fossil record and the people who actually think about the biology of the situation, of the genetics, of the ecology, and so on, we're not going to get any progress.
But punctuated equilibrium wasn't taken up. Because ever since Darwin's day, evolutionary biology has been split between those who look at the broad picture of how the evolutionary players affect each other's fate, and the geneticists, more interested in examining each of us in isolation to find out what makes us tick. The geneticists were on the brink of their own revolution in understanding our individual natures. They were overturning simplistic ideas which had held back our understanding of animal and human behavior for a generation.
I can remember being taught that the reason why animals, when they're competing for a territory or a female or something, do a lot of displaying, but very seldom actually fight with claws and teeth and so on, was that if they did fight with all their weapons, that would be bad for the survival of the species. This is what is called a group selection argument. What is being selected is something that is good for the species. Even then, as an undergraduate, I knew it was rubbish, though I couldn't at that time provide an alternative explanation for the behavior I was seeing.
The problem with group selection was that it ran counter to the basic principle of Darwinism, that we are all selfish. Individuals who act for the good of the group will never do as well as individuals who act for their own benefit. The cheats in the commune will always destroy cooperation. This was the end of group selection. But if group selection didn't work, then individual selection created its own uncomfortable problems.
If the benefit of Darwinian thinking was that it immediately made sense of all the selfishness we see around us, then it also created a problem which didn't exist in the group selection paradigm. Well, what about the altruistic behavior? What